After we find the issues in the data through the inspect process, now next thing is to clean that data that has some issue in it. So after inspect, we come to cleaning process. Now this is a vital process because identifying an issue can be done or automated using libraries, but cleanup process must be sometime done manually based on the business need or business requirement. So the clean process is to fix the issues with the data. Each issues type should be dealt differently. So this is important concept. We are going to discuss some of the flavor of issues with the data, and each of these issues should be handled differently based on this business requirement or business need. So let us sum up the issues that we can have on our data. Let us see them one by one. So first is irrelevant data. Irrelevant data are those data that are not important for us. Let us say that we are going to predict whether or not people will buy something from our, let's say, e-commerce website. Then maybe the name attribute is not that vital. We can remove it. Maybe this attribute is irrelevant data. Now the problem with this irrelevant data is that the unnecessary data, if you use them to make a machine learning model, they will skew our result. And they also take extra resources. See here, they are not that important and we are using that for the model. So it will take time, some time maybe, but it will eventually just make irrelevant importance for our model. So if you have irrelevant data onto your data sets, just remove or drop them. You don't need them, just drop it. Similarly, if you have a duplicate data, for example, if you have a column, let us say that you have a column, and in this column you have basically some information related to your, let's say, birthday. So this is the birth date, the date which you have born, and similarly you have the information of age, your age. Now you can clearly see, using this birth date and the current time, that is the present time, the date that I am recording here is 2022. So the birth year, the year that you have born, and the current year can be used to calculate the age. So this age is no longer necessary if you have this birth date. So you don't need this. So you can directly remove this age, which is irrelevant data. Now in the case of duplicate, if you have the same column, let's say birth date is here, again you have a birth date here. So that is irrelevant. That is also duplicate. You can remove one of them and keep another one. So duplicacy might also happen within the row level. Let us say that I have information about the person. Let us say I have the information here in the next data. I have a person information. Let us say his name is A, his age is 20, and he is, let's say, that is, he is a male. You can see the data has been duplicated here. The same row, the entire row information has been just duplicated across multiple rows, and it might be in our real world scenario. So what you need to do, just keep one that is unique and remove all the duplicates. That is what we need to do in order to clean the duplicates data. Next is type mismatch. So type mismatch is another type of error that we mostly get in the case of real world data. So type mismatch is within a column if the data has different type. Let's say I have the attribute X, and this is numerical attribute. Let's say most of its data is numerical, but along with this numerical data I have, let's say, that is textual data, that is, let's say, hi. So you can see this is a text. Now it is mismatched data because some of them are numbers and one data that I have here is having different data type. It is a string. It is a string. The three of them are numbers that are integers. So you can see some of them are integer, some of them are a string. So that is what type mismatch means. So in this case we need to convert the type so that all the type will be uniform. And next constraints or next thing that you need to check is non-standard values. So in the case of non-standard values, you need to apply the concept of transformation, normalization. We will be doing this. We have a separate lecture for this to discuss, and we will do it using scikit-learn library in the practical session also. So non-standard here means some of the data are bigger and some of them are smaller. Let's say that I'm collecting the salary of all the person. Let's say a middle salary man. So the person who has a middle income, let's say his salary is 50, that is $50K. I also have now collected the salary of billionaire, let's say, and he has a salary of $50 million. Now you can clearly see these data are quite different. So some of them are having low salary and the people who are billionaires are having the much more higher salary. So they are not standard. They are non-standard data. Now if I make a machine learning model using this data, then our model will be biased toward the higher value. So that means the billionaire will get higher importance on our machine learning model rather than lower salary person. So that is what we don't want. We don't want our model to be biased to anything. Our model should be neutral. It should treat each of these salaries separately. So that is what non-standard means. So this non-standard should be transformed so that our machine learning model will be accurate to predict. So that is what important concept, and we are going to talk about normalization, standardization, transformation with a separate lecture in the upcoming video. So next thing to clean up is a missing values. So this is also an important thing that we will have in the real world data, that is missing values. Maybe you are collecting a data that has something as a customer of the hotel. So let us say that you are collecting the data for the customer of the hotel, and you are telling the customer to write their name, their, let's say, their age and their agent information from where they have booked their hotel reservation, and similarly their, that is their company name and so on. So that is what you are going to collect in your form, let's say. So here will be customer name and their age, and let us say their company they own, and the agent information they use to book your hotel or restaurant. So this information you just collected, maybe it can be many more information. Now I got the customer A, he has the age 30, but he don't have a company. Let's say he doesn't own any company. So this field will be empty. Now this field will be not available because he don't owns any company. So this might be a real world scenario. Maybe he has some agent that he used to book. Now in the second scenario, maybe there will be some person who does not want to disclose their age information. Maybe that is not available now because they don't want to publicize their age information. Now as a data collector, we need to validate, or we need to validate their privacy. We need to confirm their privacy. We don't have to make them obliged to give us their age by forcing. So they should be on their hand whether to disclose this information of themselves, the personal information of theirs. And maybe he has given their company name and it is private company, and let's say the person B did the online booking by himself. He does not use any agent to book this hotel. Then this information will be also not available. So in this way, in the real world scenario, most of the data might go missing. Now in the case of missing value, you can either drop it either you can impute it or you can also give flag to it. Now what does that mean is, let us say I have the null values, that is NA values. In the case of NA's values, you can just directly drop those NA values, because those NA values might not be important for us, so you can just entirely drop it if you have the large sample. So which means if you have a huge data set, you have a huge collection of records. Let's say your data is quite a long data. You have collected many information of a customer. Then removing some of the NAs might not get affected to machine learning model. You can directly drop them. You can directly drop them because you have too much of data, and dropping some of the NA value might not affect your machine learning model. That might be one case. But what if you have collected only limited amount of customer? That means you have a small sample. You no longer have a large sample. You have only collected a small amount of customer. Let's say you collected 1000 customer data and it contains NA values. Now, let us say that from this 1000 data, you have a row that contains 200 NA values. Then removing 200 datas from 1000 records will be making too much of difference, because the remaining data that you will have is only 800 now. After removing those 200 record entirely, you will have only 800, and that might make a difference. So if you have a small sample, then in that case, rather than dropping these NA values, you can use the concept called as impute. Impute means assigning or filling this NA with any other values. Maybe you can fill this NA with 0 values. Maybe you can replace this NA with mean or average value. You can replace this NA with median values or any custom values that you want. So that is what imputation means. So rather than removing, you can replace these NA values with some other values. And that is what imputation means. You can also give the flag to it, something like, let's say, some unique characters like $. So whenever we have NA, give all the NAs the $ values, so that later you can just analyze those NA value differently. So for that reason, you can also give the flag to it. And similarly, we can find the outliers onto our data set. And if you have an outlier, then you can simply remove, or if you have a smaller amount of data, or if the outlier is also important for some machine learning algorithm based on your business need, you can either remove or keep it. So that is what cleanup process means. And this cleanup process should be done continuously, should be done iteratively.